Okay, so anyway, Emma, good job. Yes, can be written as a fraction. It is for sure a rational number. Then Brianna said rational numbers are integers that can be expressed as a fraction. Very good. For example, 1/2. A half can be accurately expressed as a fraction. Pi is an irrational number, so I like how you contrasted that because it's ongoing and cannot be accurately expressed. Good. Hi, how's it going? Glad you could join us. We just posted, so I'm going through the post. And Katie's joining us too. All right, and then Elliot, number 1, it's a whole number. Okay, so the number 1 is a whole number. So that's not exactly the definition of you didn't tell me a rational number on that, Elliot, but you did tell me what a whole number was, so you told me something else you know. David, rational numbers are numbers that can be confirmed and can be proven, and examples of a number that isn't. Okay, you know, that's actually also true. Good point on that one because we can compare it to, yes, imaginary numbers and like Brianna said too, irrational numbers. Alicia, good, simple fraction. And Miriam, a rational number is a fraction. Okay, good. Very good. And I like, Miriam, that you put 5/1 because, you know, that's the same thing as 5. And a lot of times people don't know that 5 is actually a rational number. And then, Elliot, I meant number 1. Oh, as in the first question? Oh, it's a whole number. Oh, I see what you're saying, Elliot. Sorry. You're not saying the number 1. You're saying, okay. Okay, so we'll look at it. So you guys, good try. I'm very proud of you guys. Way to go. All right, going back to our webinar then, because obviously we're going to be doing some stuff with rational numbers, which is why I asked you guys that question. So what are we doing today? We are going to explore the meaning of rational expressions, which is why I wanted you to know what rational numbers were. And then we're going to simplify rational expressions. This is the crux of this whole entire week. If you can simplify a rational expression, you will do awesome this week. And that is where we're starting off with rational expressions. So obviously we're going to be graphing them and solving them and simplifying them and doing all that stuff that we do. But you guys are really doing well with all that kind of stuff. So I feel like most of you guys will have a really great background and be able to do awesome this quarter. So, important info for success. This is your first week. I know quite a handful of you guys have already completed assignment 1. Way to go. By the way, hi Katie, I saw you come in too. And some of you guys even completed assignment 2 already. But remember, there's only 3. So don't get behind. Do assignment 1 today. Make it a huge priority. Get it done. And then just something to kind of keep in you guys' heads. And most of you guys do this anyway, but no matter what, don't skip, because if you suddenly don't work for a week and then you go, oh no, we're on week 4, and then you jump to week 4, you're going to be horrible at it because you missed week 3 or week 2, and you need that foundation to be successful in week 4. So just to kind of tell you guys, no matter what, don't skip. You know that I don't dock you for late work. I just want you guys to master the material. That's all I care about. I just want you to learn it. That's the most important thing. If you can learn it, then I'm happy. All right, any questions? Emma, question. Oh, you do have a question for me. Yes, tomorrow I will be at Gateway. And okay, good. And so good, Emma, and maybe today that question will get answered too in the webinar, but I will definitely be at Gateway tomorrow, so we can work on it together. Okay. All right, you guys. So let's look at a rational number. And you guys are right on. Right? You all said, most of you, that it's a real number that can be written as a fraction. So that's why we call it a ratio, right? A comparison between the numerator and the denominator. So 1.5 is a rational number. This is true because it can be written as 3/2. It can be written as a fraction. So where are we going with this, you guys? Well, rational numbers relate to rational expressions. And here is why. A rational expression is really a ratio, so there's your rational number ratio, between 2 polynomials. And you guys already just finished a whole quarter working with polynomials. So you should see that and be like, oh, polynomials, I know how to deal with those. So we're looking at a rational expression, so a ratio. Okay, and that is why a rational expression is called a rational expression, because it's a ratio of 2 polynomials. All right, so that gives you a little bit of glimpse into your future. So what I want to start with for you guys in your notepods, I'm going to give you guys some tasks. So here's what I'm going to do. There's 1, 2, 3, 4, 5, 6, 7, 8 of you guys. So I'm going to take 1, 2, 3, 4, 5, 6. Okay, so we do have 8 notepods. So you guys, everybody grab a notepod. Just put your name in any random notepod because I'm going to choose you by notepod that you pick. So some 4 of you guys are going to get a harder thing, and the other 4 of you guys are going to get a little bit easier. For now, of course. All right, so almost everybody has a notepod, I see. 1, 2, 3, 4, 5, 6, 7. Who am I missing? Oh, nope, Katie, are you in that one? All right, good. All right, here's what we're going to do, you guys. I'm going to go backwards. So, well, not really backwards. All you guys that are in notepods 1, 2, 3, and 4, so that'd be Emma, Miriam, Katie, and Brianna. I want you guys to factor the denominator in your notepod. Factor, right? Factor probably by grouping. And then all you guys, so that'd be in student 5, 6, 9, and 8. So that'd be Elliot, David, Trevor, and Alicia. I want you guys to factor the numerator. So think about GCF. All right, ready, set, go. In your notepods. So you guys are teams. So the first 4 of you guys are a team. And the second 4 of you guys are a team. And now we have Unique. Hi, Unique. How are you? Unique, you can be in notepod 7 underneath my video image. Me waving at you. You are, here, wait, down there, student 7. So Unique, what we're doing is we're on teams right now. So student 1, 2, 3, and 4 are on a team, and they are factoring the denominator right now. And, oops, uh-oh. And then students 5, 6, 8, and 9 are factoring the numerator. So Unique, I'm going to give you a choice. You can either factor the numerator or the denominator, whichever one you want to factor. All right, let's see, you guys. We should make it a contest. Oh, Unique, student 7 is right under my picture. Do you see me smiling at you and waving? If you look down below my picture, you'll see, yep, there. It's kind of hidden. It's kind of hidden. I'm squeezing it in over there. So that can be you. So Unique, is that, I guess that's what you're going to choose, the 5x minus 10. All right, help your team out. Oh, did you factor it already? Okay, good. All right, first team, you guys are making good progress. Oh, Miriam, I think Miriam has already maybe factored for you guys. We'll see if you guys all get the same. And then we're going to decide if you guys are all correct. Okay, you guys are looking good. So it looks like David and Trevor and Unique are super fast with theirs. And Elliot, I know you can do this. You did it yesterday beautifully. I saw it. It looked awesome. And then, oh, your notes. I know what you're going to say, but memory. I thought you were going to say notes. No, your memory was good yesterday. You had a really good memory. You did. It must be your philosophy books. They're helping your memory. Not today. Maybe because is it snowing over there, by the way, where you guys are? Because it's snowing. It's snowing over here. There's positive ions in the air that affect, how you feel sometimes. All right, so let's see, Katie, Miriam, you guys are already factored. Brianna, you are working on it, and Emma, I think you're missing a number inside of your parentheses or something like that. You kind of have like a partial factor going on. All right, you guys are finishing up. Just going to organize this a little. over here. All right, so probably isn't exactly fair because whoever had the denominator had a little bit longer to go. But I will say this, you guys, nice job. Very nice job. Unique, you were helping the other team out too. I don't know what your 5x plus 4 is though. I'm confused on that one. But your x plus 4, x minus 2 is good. All right, so nice job, you guys. So I'm glad that you're remembering your factoring, hopefully, since we have, oh, crystals falling slowly from the evil skies of pollution. That's very beautiful, Katie. In your English class, Miss Scritchfield's going to be very happy with that. Oh, 5 over. Oh, you're already simplifying. Unique, unique. You're just working ahead. That's good, though. Okay. All right, well, you guys, great job. So everybody learned that on this first one, our GCF was 5, right? So we divided both terms by 5. Elliot, remember that? Oh, yes, you have that. So we pulled out the 5. 5x divided by 5 was x, and negative 10 divided by 5, remember the negative, which you guys all did, is minus 2. So way to go, team 2. We're going to call you guys team 2. And then on this one, you guys also did a good job. You split up this middle term, and maybe some of you guys might have used the x method to split up the middle term. And if you did, you probably did something like that. So then you knew that that term split it up into x squared plus 4x minus 2x. And some of you guys are probably getting good at doing it in your head, especially if there's a 1 in front of the x squared, because then it's kind of easy to see it. And then you had your groups, right? So we factored out an x, and we got x plus 4. Then we factored out a negative 2 here and got x plus 4. Then we still had our two groups. We knew that x plus 4 can be pulled out, which leaves an x from the first group and a minus 2 from the second. So, looks like you guys are all did that super fast and very effortlessly, which is good, hopefully, since we did that all quarter 3. Okay, so the key word here is simplify. So you guys already know, your prior knowledge, you already know how to factor. We've been doing that and doing that and doing that, and so it's like second nature to you guys, and I'm seeing that, and I like that. I like how you guys can do that. So to simplify, now all we have to do, this is the fun part, and this is what Unique was already doing, is we're just going to cross the things out that are the same between the top and the bottom. So on the top, x minus 2 can cancel with x minus 2. Anything that's connected with a plus or a minus is one thing. So x minus 2 is not x, and it's not 2, it's x minus 2. So you can only cancel the whole thing out. So then that would leave our final answer as 5 over x plus 4. And that is how we simplify, and that's what we're going to do all week. So the first lesson you guys have, you're just simplifying the basic rational expression. Then in the second and third lesson, you're actually multiplying, dividing, but I'm going to show you what that means. But in reality, all you're doing is simplifying two expressions that are being multiplied or simplifying two expressions that are being divided. So as long as you can do this, cross things out, factor, you'll be in really good shape. All right, you guys. Any questions on that simplifying? Okay, hopefully you guys are good. The only thing I did was cancel things out. That's the only new thing I did. All right, you guys, so I'm going to say both your teams looked good. You both won. Okay, so where did this one come from? Hang on a minute. Okay, so what I want to do actually on this one, why don't you guys go ahead and simplify that numerator, and I'm going to add something else on. So you guys go ahead and factor the numerator, not simplify, go ahead and factor it real quick. I don't know if you guys can see it anymore. Sorry. I'm going to put something here. Sorry, you guys probably can't see it so well now. Oops. Oops. Okay, having some trouble here with this. Okay, so minus 81. All right, so I just added to our equation here a little bit. Okay, so sorry you guys. So go ahead and factor. Okay, this time we're going to switch. So let's do this. How about if we take student 1, 2, 3, and 4. This time you guys are going to factor x squared minus 81. And then we're going to have everybody else, 5, 6, 8, 9, and 7. Can't forget you, Unique. Factor the x squared plus 10x plus 9. So go ahead and factor this, you guys. Just factor those two. So the x squared minus 81 and the x squared plus 10x plus 9. Let's see. Okay, you guys are looking good. I'm just going to set up for our solution. All right, let's see, how's it going? All right, Miriam is working. Emma, I think you have the last problem on there still. Katie, okay, good. Brianna, you're oh, on the x squared minus 9? Okay, so here, or x squared minus 81, sorry. Is that a special factoring pattern, perhaps? Think about special factoring patterns. All right, Elliot, good job. Factored that already. Very nice. Ah, Brianna, yes. So see, your team is helping you. Brianna has listed what that is to give you a little hint. Unique. Do you mean 10 on that? Are you thinking 10? X plus 9, x plus 10? Double check. All right, Alicia, x squared. So I'm thinking you might have broken up your middle term, but remember that the two things that you break the middle term up into still have to add together to be 10x. And then, let's see, David's off and running. Good job, good job. Okay. Almost there, you guys. Take another, 30 seconds. All right, Miriam, I think I get what you're doing. A little shortcut, I see. And Emma, you're kind of thinking, I know it's in your head. All right, so, all right, I think we're gonna, you do. You remember, Emma, I know you do. All right, once I show you, you're gonna be very upset with yourself. Okay. Let's look. I think we can go because it looks like both teams have some solutions. And let's go ahead and look at this x squared minus 81 first. So Brianna wrote perfect squares, right? So anytime you have two terms, your brain should automatically think, oh, I could have a difference of squares, especially if it's a minus sign. And if we take the square root of x squared, that's a perfect square. and the perfect square of that is x. If we take the square root of 81, that is a perfect square too, and that's 9. So if you guys remember how to factor that, you can factor it into x minus 9, x plus 9. And Katie, you had that right away. Very good. Miriam, I think that's what you meant with the plus or minus as well. So good job, team. Very nice. Okay, then let's look at this bottom one here. So David's got it, Unique has it up already, and Trevor. Okay, good job, you guys. So you guys are factoring by grouping, and you figured out that this middle term can be split into, looks like 1x and 9x, right? Whatever you split it into has to still sum to 10x. So when you guys factored that, you ended up getting x plus 1, x plus 9, and you just did that through your grouping. So that's perfect. Good job. All right, so how do we write this in here? Okay, well, we have the 3x plus 1. That's already factored. We don't have to factor that. So when you see this times in here, well, isn't really the 3 and this x plus 1 being multiplied? So if we're going to do times or multiplication, you can just write the parenthesis right next to it. You can leave off the times because we're just multiplying. So I could write x minus 9 here, and I could write x plus 9 here. Doesn't change anything, right? Multiplication is just everything being multiplied. I could do that on the bottom too. I could put x plus 1, x plus 9, and then I can have my other x plus 1 here because that's already factored as well. Okay, so you guys, this is your second assignment basically. And so far we haven't really done anything different than we did on the first one where we simplified. So now after multiplying, and actually, did we really multiply? We didn't really multiply anything, right? We just still factored, and now we're just still going to simplify. So if I simplify, I'm just going to cross out, once again, things that are the same. So here's 1x plus 1 that I can cancel with this one. Here's an x plus 9, I could cancel it with that one. And then I can write my solution, whatever's left. So I've got this 3 out here, and I've got an x minus 9. And then on the bottom I have x plus 1. Can't cancel anything else out. Sometimes what you can do is multiply the numerator together, whatever you have, and see if you can factor it again as a quadratic. In this case, we would just get the same answer if we refactored it. But that's basically all you can do from there. So I'm not going to show you the division one, but if you think about division, just to kind of give you guys a heads up, if I were to multiply 1/3, or not multiply, sorry, divide 1/3 by 2/5, that's actually the same thing as multiplication. It's 1/3 times 5/2. So really, division is just multiplication if I flip this second fraction around, okay? So this week, you guys, it's just the same thing kind of over and over again. It's not too bad, and you guys are already doing really well. Oh, you have to go to work, Alicia. Okay. Well, we're pretty much done. Alicia, hopefully you just said that. So we're going to do our ticket out if there's no questions. So you guys, any questions from anybody? Any questions? Comments? Brianna is all good. And you guys are going to do your first assignment today if you haven't already done that, right? Right, yes. Oh, yes, Laredo. All right, well then let me give you guys your ticket out. Your ticket out. So what you want to do is go back in, and now what I want you to say, and hopefully at this point now you'll have this answer, is how then is a rational expression, what we just were working on, related to a rational number? So not too difficult today. Oh, excluded numbers with excluded numbers. Oh, in the domain and the range. I think that's what you're talking about, Emma. Okay, that's actually a good one. I probably should have gone over that today too, but that's probably what you want tomorrow. So did you say you're at Gateway tomorrow? I think you did. Okay. Then we can look at excluded numbers, but yeah, I mean, if you think of those as anything that makes you have division by 0, that's bad. So those numbers are called excluded numbers. They are not, we don't want those in our domain. But we'll go over some examples so that'll be more clear too. All right, guys. Well, good job today. You guys always do a really good job. I totally appreciate your attendance. You guys are awesome. So have a good afternoon, and I'll see you all later.